So we'll see today SSAS models. We'll see in the SSAS models. Here we'll write down SSAS models. So SSAS is a SQL Server Analysis Services. SSAS is a SQL Server Analysis Services, and here we can call it as OLAP model. SSAS models we can call it as OLAP models, and there are two models. Two models. There are two models in SSAS. So one is multi-dimensional model, multi-dimensional model. So the other one is a power tabular model, tabular model, tabular model. So in SSAS there are two models. One is a multi-dimensional model. The other one is a tabular model. So so as of now we have seen so how we can pull the data from on premises databases and on premises data sources and online data sources, online databases and online data services. So now here we could see how we can pull the data from on premises databases, but which is SSAS, which is a tabular data model. So and here we could see there are two models, I could say tabular versus OLAP. OLAP is nothing but multi-dimensional model, and tabular, which is called as a power pivot level. And there are two models are there. So we can create SSAS multi-dimensional model, and we can create SSAS tabular model as well. But which one is a better option to create the project for this? So let me go through inside. So SQL Server offering, there are two different types of cube options. So one is the tabular model. So the other one is a multi-dimensional model. So there are so the comparison between these two models will be shared, and the main benefits and the drawbacks of these both, which will be discussed during this next slides. So let me go to the next slide. Yep. So here if you see the comparison between the here you could see the comparison between the OLAP model and then tabular model in memory and the tabular model direct query. Tabular model in memory is nothing but import. So I was telling right earlier we have two data modes. So one is the import data mode, the other one is a import data mode, the other one is a direct query. Here also we have in the tabular model we have two models. One is a tabular in memory, which is called as tabular import data mode, tabular direct query data mode, and the other one is a power pivot. Power pivot is nothing but a excel power pivot. This one is excel power pivot, and this OLAP is multi-dimensional cube, MDX multi-dimensional cube. So SQL Server offering, these are the version in 2008 plus. So in 2008 plus, in 2008 R2 we have a power pivot, and 2010 also we have a power pivot add-on is there in the Excel, and 2012 version is there for the tabular model 2012 version. And SQL editions are the standard edition and enterprise edition, and this is for BI, business intelligence enterprise edition. And languages, so we have a two different languages. So this is very important. We have two different languages. One is MDX language, the other one is a Dax language. So I was telling right earlier, so Dax language, which is used to read the data from the Power BI data model. So not only to read the data from the Power BI data model, so it will be useful to read the data from the Power BI data model and power pivot power pivot, and also it can be used to pull the data from SQL Server analysis services, analysis services, which is tabular model, and Azure analysis services, Azure analysis services. So Dax language is a data analysis expressions, which is having a collection of functions, operators, and which is used to evaluate the expressions during the runtime. And these Dax expressions can be used in the Power BI and Power Pivot, which is an Excel, Power Pivot, which is in Excel. So, and also this Dax language can be used in SQL Server analysis services, Tabular model, and Azure analysis services. And this multidimensional language, which is used to pull the data from the multidimensional data model. As I was telling, there are two models. One is a multidimensional data model. The other one is a tabular model. These two models are existed in the SSAS only. SSAS, we have two models. One is a multidimensional data model. The other one is a tabular data model. This multidimensional MDX is nothing but multidimensional expressions. So this MDX language is specifically used to pull the data from the multidimensional data model, and this DAX language which is used for the tabular model. This DAX language which is used for the tabular model. So now go back. So let's say there is a data compression. So this tabular data model which is used in the vertipack velocity. So tabular data model which is used in the vertipack vertipack x velocity engine. So this tabular model will use the vertipack x velocity engine, which is a column store data, which is a column store data, which is a column store data, and which is having high compression, which is having high compression, high compression. So nothing but for an example, normally the data would be stored in terms of row store. Normally the data would store in terms of row store, but in tabular model, the data would be stored in the column store, column store, column store. For an example, row store and column store, what exactly the difference is? For an example, we have employee number, employee name, and then there is a department, department. For an example, employee number 101, employee name some A, and department is sales department, and employee number 102, department is some BBB, and here also this is the sales department, and 103 and CCC, and this would be some HRM, human resource marketing department, and 104 and DDT, and this would be some HRM. So now while storing the data, while storing the data in the column store, so it would not store all the data. So it would store the data in terms of column store. Nothing but it would store the unique values in the system. So for an example, employee number would store 101, 102, 103, and 104 because all are unique values. And employee name also it would store all the unique value. When it comes to the department, it will store only the two values. One value it would store as a sales, the other value it would store as a HRM. So it would not store the four values because it has all the four values which are the duplicate. So all four values which are duplicate. So instead of storing all the four values, it store only the two values. It is called as a compression. High compression, high compression. Instead of storing all the four values, it store only the two values. And while mapping, while retrieving the data, again it map this sales with this particular 103, 102, and again this HRM will map with the 104. So while retrieving the data, it automatically maps the data with this particular records, and retrieves the data to user. So this is called as a compression. So this is called as high compression. So for an example, we have some. For an example, we have some 1 billion records. 1 billion records. For example, we have 1 billion records in the system. So now you are trying to fetch 1 billion record from the system, and out of 1 billion records, this department has most of the columns are unique. If you see out of 1 billion records, you have only the four records are unique. Four records are unique. So how much space would be occupied here? Instead of storing 1 billion records, it would take much space. So here it would take only the four records versus billion records. See how much compression is there. So while storing the data in the column store, instead of storing the 1 billion record, it store only the four records, which is the sales department, HRM department, insurance department, and then finance department. Only the four records it would store. The rest of the records it won't store because those are the duplicates. It will store only the unique values. And here also, if the employee number is more than 1, it will store only the one value. And while fetching the data, it would give the results to the user. Well, it creates the mapping internally. Is this clear? So now, data compression. I was telling, right, the data compression is 10 is to 1. So here the data compression is 10 is to 1, but here the data compression is 3 is to 1. And mostly let's say if the size of the project is very huge project, I mean the data size is a huge, then you would need to go for OLAP cube. If the data size is huge, then go for the OLAP cube. If the data size is small, then go for tabular model, which is in memory, or tabular model which is in the direct query. So and it support, and there is a Excel analysis. You could analyze the Excel data by using the tabular model, and also you could analyze the data by using the OLAP model itself. And you could implement the security in the tabular. You could implement the security by applying roles and creating the roles and mapping the roles using the OLAP model. Here also you could apply the security in the tabular data model. And there are some features, advanced features which are there in the OLAP, and those advanced features which are not there in the tabular model. And this is a self-service BI tool. So tabular Power Pivot is a self-service BI tool, and you could connect with the many data sources. For an example, you have Excel data source, or you have the SQL server. So you connect with many data sources. I mean, you could pull the data from the many data sources. And this OLAP is a traditional BI tool, and this tabular in memory also, it comes under the traditional BI. And here the calculation flexibility. So when it compares to the OLAP model and tabular model, and OLAP model has a calculation flexibility. And when compared to the reporting performance, and both will give the high reporting performance. MDX will give the high reporting performance. Tabular and model also will give the high reporting performance. So when you compare with the report flexibility, right? When you compare with the report flexibility, and tabular model will give high report flexibility. So display detail. So even you could display the information in terms of graphics by using the tabular model. So this is how the data would be. So is this clear?
Yeah.
So now go back here. So, and there are some concerns here. You could see here there are some advantages and disadvantages by using the tabular model and multidimensional model. So more performance than OLAP in majority of the cases. So when you are using the tabular model, it will give you the more performance than multidimensional model, and it is easy to develop than the multidimensional model. And here you don't have much hectic process, and it is a easy process you could directly implement by using the tabular model. But when you are using the multidimensional model, the complexity of the model is very high. Sorry, the complexity of the data model is very high, and it is hard to develop the model by using the multidimensional model. And the technology for the future is tabular model, and integration with the Power Pivot. Already it's been integrated with the Power Pivot in the tabular model. And the disadvantages is there is a new product, so still enhancements to come. So still I think this portal is almost created in long back, but the thing is all the new features also came to the picture, and came to the tabular data model, and all new features has been enabled. But the thing is, there is a limited to the RAM available, that also has been increased. And mid-sized projects, this is good for let's say for an example, if the data size is 1 TB or below 1 TB, then go for tablet data model. If the data size is more than 1 TB, then go for MDX data model. Is this clear? And there are some advanced computations which are not available in the tabular model, and here it performs high complexity than tabular model. So these are the comparisons between the tabular model and multidimensional model. So today what we can do is we'll create a SSAS tabular model. Okay, today we'll see how we can create a SSAS tabular model, and how we can create a measures, how we can create a calculated columns, and how we could create the similar way, the same way. So whatever we have created in the Power BI using the SQL server, the similar way here also we are going to create a tabular data model. So let me open the tabular data model. Go to SQL Server 2012, and here there is a tool called as SQL Server Data Tools. So go to SQL Server Data Tools and go to SQL Server Data Tools. Go to File, Open. I'm going to New Project. Go to New Project, and here you have the Analysis Services Tabular Model. Here you can go ahead with the Analysis Services Tabular Model. So already under the PBA work, we have all the information, product sales analysis, product sales info we have, and all these cubes are already available, existing cube. Excuse me. So we'll select the analysis services tabular project, and here we are going to select tabular model. So sales information. Sales information. So the name of the project is the sales information, and I'm trying to give under the PBA work. Let me make it okay. Sales information. So once as soon as you created the model, here you could see on left hand side you could see the model. And now go to model and import the data from this particular data source. The first step is you have to create a new project. The second step, go to model, import the data from the database. Now I would like to import the data from the Microsoft SQL Server, and even you could import the data from the Azure itself. Is this clear? You could import the data. You could import the data from Microsoft SQL Azure, or else import the data from Microsoft SQL Server. So now I'm trying to pull the data from the Microsoft SQL Server. Go to next, and here you need to provide the server name. So I would need to provide the server name here. So let me go to the server name. So for that I would need to open the Microsoft SQL Server. So let me open the SQL Server Management Studio. So here is the server name. Let me copy this server name and then go back here, provide the server name. Windows authentication, that should be fine. So take the data warehouse as a AdventureWorks data warehouse 2008 R2. Go to next. And here you would need to provide the username and credentials. So I would need to give ent/KAKARA2. Give the password. Let me go back here. So out of these tables, which tables, what are the tables you wanted to pull it? So I would want to pull the dim customer, dim date, dim geography, dim product category, dim product subcategory, and then fact internet sales, fact internet sales. So I would want to bring only these tables. So one is the fact internet sales, dim product category, dim product category, dim product subcategory, dim date, dim customer, and then dim geography. There is a dim geography. All these are the tables. So now let me finish it. So as soon as you pull the data, so you try to pull the data from the tables, the backend tables. So now you could see the data. So now we got the data into the model. So now we got the data in the model. So now we got the data in the model. So now let me go to one by one table, dim product. So I would want to keep only, let me go to the model. Here you could see there are, I was telling that in Power BI, there are three views. What are the three views in Power BI? There are three views. On your left hand side here, you could see there are three views, right? In the Power BI. What are those three views? One is the report view. The other one is a data view. The other one is a model view. There are three views. Here also we have two views. One is the data view, the other one is a model view. This is called as a data view. And if you go here, this is called as a model view. This is called as a model view. And if you come here, this is called as a data view. So now we'll go to the model view. So this is called as a model view. So now in the model view, so I would want to bring a few columns. I don't want to bring all the columns. All the columns are not required. So whatever the columns are not required, so those columns you can hide it. So I would want to bring product key. Product key also I don't want. I would want to bring only the product category name. So bring let me bring all other columns hide hidden from this all other columns hidden from this particular table. So let me select all. Let me remove English product name. So I have done this. Right click and hide from the client tools. So now you could see all the columns have been hidden. Only the product category name. Only the product category name is selected. The rest of the columns, all the columns are hidden. All the columns are hidden. In the similar way, so here also you could see that. So I would want to create only one particular column has to be English product subcategory name has to be enabled. The rest of the columns has to be hidden. Right click, hide from the client tools. So now this is also hidden. Is this clear? In the similar way, you have to hide it. In the similar way, you take the English product category name. There are all or English product category name. You have to keep it. The rest of the things I would want to hide it. So let us hide it. So I have hidden the rest of the columns. In the similar way, you have to keep for all other things. Dim customer also. Dim customer also you have to keep the same. So dim customer I have selected all. Out of that I would want first name and the last name. So the rest of the columns I would want to hidden. So let us hidden it. So right click and then hide from the client tool. So they are also hidden. They are also hidden. They are also hidden. So in a similar way, go to geography. Geography also I would want to hidden. So let me keep the English. Let me select all. Let me keep English country region, state provenance code, state provenance name, and then city. The rest of the columns I would want to hidden. So hide from the client tools. So the rest of the columns hidden from the hide tools. So now I'm done with this. So let me go to date table. Date table. So let me hidden all this. Hide this. Out of that, I would want to pull only few columns. Calendar year, calendar semester, calendar quarter, and then English month name, month number of the year, and English month name. So I would want to keep only these particular columns. So month number of year and English month name, calendar quarter, calendar year, and then calendar semester. So the rest of the columns I would want to hidden. Let me hidden from the client too. So those are hidden. And only the last one table is there. Let me hidden this table also. So let me go back to this particular and select all these things. Out of that, I would want to keep sales amount. I would want to keep total production cost, tax amount. I would want to keep and total product cost, sales amount, tax amount, and unit price, and then order quantity. So let me hidden the rest of the column. So it went away. Unit price, order quantity.
Hey, ¿cuál es el
So let me select all.
Bisa diurus tadi.
So let me select all. So out of that, let me select all. Out of that, you would want to keep only the few columns. So let me select sales amount, tax amount, total production cost, the quantity, unit price. So the rest of the columns you can hide it from the client tools. So now it's completed. So now we are done with this. All the list of tables we are done with this. So the first step is whatever the required columns, you can keep all the required columns. So whatever the are not required columns, you can hide from the client tools. That is the first step. The second step, go to the this particular thing and create some particular columns, calculated columns. So I'd want to create some calculated columns in the this particular table, dim date. Go to dim date and create one particular new column. So I would want to create one particular new column. So let me create a new column equal to left of dim date of left of dim date of date key comma 4, and then concatenated with hyphen and and again mid of hyphen key. So you are going to concatenate it with the hyphen key and then mid of dim date of date key comma 5 comma 2 and again concatenation and right of right of dim date of dim date key comma, you have to apply the leftmost two characters, right of two characters. So now I'm done with this. So let me make enter. So once if we make an enter, so the new column will be created here. So this new calculated column, you can make it as date. So date. So I'm done with this particular thing. So now select this particular column, right click, and here you have or else what we can key. Let me select this. Date format is there, data format, column name, data type. So data type, you have to make it as a date. So now this is clear. And data type and format, let me keep the format here. Somewhere the format would be there. Sort by column, summarize table detail, hidden false description, default label, data format. Okay, here I have the data format. So I would want to keep YYYDTMM. So this format I would want to keep. So now I am done with this particular model. So let me save this. So let me save this, save and then save all. Now I'm done with this. In the similar way, you would want to create the similar way. So go back to the fact internet sales and create one more column, which is the order date. Let me go here. Let me create one particular column, which is called as the order date. How you can create the same formula. So whatever the formula you have created, the same formula you have to create. So left of fact internet sales of due date key. We have order date key is there, right? So take the order date key, comma 4, and you have to keep and let me concatenate with the hyphen symbol and Let me take mid of 5 comma 2. So you have to keep fact internet sales of order date key 5 comma 2, and and concatenate with the hyphen and write off fact internet sales fact internet sales of order date key comma 2. So now we are done with. So here from this particular phase, we have extracted four, the first four digits of that order date key, and then concatenating with the middle of two digits and the last rightmost two columns. So we were pulling the data from the order date key and then concatenating with the hyphen symbol. That's it. So we are trying to generate a date column here. So let me generate a date column. So we have generated the date column. So let me make this as order date. So this is as order date. So let me select this particular column, and here go to data type. Data type, I would want to make it as a date. So now go back to the general. So let me pull this as YYYMMDD. So now you're fine with this. So let me save it now. So now I'm done with this particular thing. So go back to the dim product, go back to the dim customer. So I would want to create one calculated column. So we have seen, right, how we can create a calculated column in the Power BI. In the similar way, here also you can create the calculated column. So I would want to create the calculated column of full name equal to first name plus last name. How you can create the calculated column? In the similar way, here you can go here and then click on equal to dim customer of dim customer of first name, dim customer of first name, and concatenation with this particular hyphen and dim customer of last name. Now let's make it okay. So now you could see the full name. So this is the full name. This is clear? So this is how we can create a new calculated columns. So the calculated columns you will be creating like this. And go back to the fact internet sales again. So I would want to create some new calculated columns. How you would want to create the calculated columns? So I would want to create order quantity into unit price is a line total. So order quantity into unit price is a line total. So how you could create? Come here, and then here you would want to create fact internet sales of order quantity, fact internet sales of order quantity, order quantity into fact internet sales of unit price. So line total equal to order quantity into unit price is called as a line total. So here I would be creating one more column. So this you can call it as, so this you can call it as line total. So this is how you could create. This is how you could create the calculated column. Is this clear? How you could create the calculated columns? Is this clear? Same way, similar way. Whatever the calculated columns you have created in the Power BI, similar way you can create the calculated columns here as well. The similar way. So I have created the calculated columns here as well. So now let me save this. Let me save it. I have saved here. So now go back here. I would want to create some calculated measures. So how you could create the calculated measures? So let me come here. So I would want to create some calculated measures. Let me create the calculated measures. So here I would want to create total sales. Total sales equal to sum of fact internet sales of total sales amount called as total sales. So as soon as you press right, you could see the value here. You could see the value here. This is called as a total sales. Is this clear? This is called as a calculated measure. Total sales equal to sum of fact internet sales amount, which is called as a total sales. This is called as a calculated measure. In a similar way, you could create as many as calculated measures. So now I would want to create some calculated measure. Let's say, for example, I would want to create country-wise sales, some Germany-wise sales or France-wise sales, some country-wise sales. So for an example, let me take here. I have taken the total sales. Here I would want to create some country-wise sales. Let me take the country-wise sales. Click here and go back here. I want to take Germany wise sales. Germany wise sales. Germany wise sales equal to sum of fact internet. So here I would want to create calculate of sum of fact internet sales amount, fact internet sales amount. So you can make it as fact internet sales amount, comma, dim geography, country region name, English country region name equal to Germany. So let me open. Now I'm done with this. So this particular Germany here, it has closed. This is sum of sales amount. Let me take this sum of fact internet. Sum of fact internet sales amount. One brace is completed. Comma dim geography. Comma dim English country region name equal to Germany. So now I think this is not required. I think. So let me create this particular formula. So now you could see the sales. Is this clear? This is the Germany wise sales. In the similar way, you could create as many as country wise sales. For an example, you go to the dim geography, and here you can go to the city. You can go to the English country region name. Here we have the Germany. In the similar way, I would want to create Australia, Canada, and then France sales. In the similar way, you could create the Australia, Canada, and France sales. So let me copy with this. So let me go here and create here. So this is called as Australia wise sales. Australia wise sales. And here you could keep Australia. Is this clear?
Yeah.
Australia wise sales. So let me click on here. And this is Australia wise sales. And here you could see the sales information. If we keep cursor here, it would automatically display. So this is the Australia wise sales. And let me so go back here and here how you could create. So here whatever we are creating, all these are the calculated measures. Okay, here whatever we are creating, all those are the calculated measures. So now we are done with this. The similar way you can create one more for Canada. So let me copy here, come here and then create here, and this you can make it as Canada. This you can make it as Canada. So now I'm done with this particular thing. So now I'm done with this. So let me save it and then publish to the server and then see the results. So let me save it here. Let me save it. And now go back to the sales information. Right click, go to properties. And now in the properties, we have seen this is the SQL server and everything is there. This is the server name. This is the edition developer sales and then everything would be there. So go back here and then right click, build it. Once build succeeded, you can deploy it. You can deploy it. So this will go and then deploy to the server. Okay, this will deploy to the server. Right click and go back to the SQL server. Go back to the here and select analysis services. Now I'm in analysis services. Connect to the analysis services. Now you could see the sales information. Is it populated? Is it deployed? Is it deployed or not? It's a deployed. So now go back to the sales information and come to this particular browse. Right click on the sales information, go to browse. Once if you go to browse, and here you could see the information how it would be. So now I would want to create the measures. So here I have three measures: Australia wise sales, Canada wise sales, Germany wise sales, and total sales. So let me create the total sales. This is called as the total sales. This is the total sales, and this is Germany sales, and Canada sales, and then Australia wise sales. Is this clear?
Yes.
So this is how you could browse the results in the SSAS browse. So this is called as a model. So this is how you have to browse it. Okay. So as of now, I am browsing. So as soon as your model is ready, so what I can do is I could create the model in this. I could create I once if model is ready, so we can pull this model data into the Power BI SSAS tabular data model in the Power BI. So now I have created one particular I have created one particular tabular model. I have deployed it, and here you can browse the data. So let me browse the data. Whatever the data you wanted to browse, you can browse it. So go back to that tabular model and create some particular calculated columns. And previously we have seen that we have created many measures, right? We have created so many calculated measures. You could create all calculated measures here as well. So for an example, total MTD and total YTD. Here we could see total MTD and total YTD. You can create total MTD and total YTD as well. For an example, here I am trying to create total MTD. Let me create total MTD sales. Total MTD sales equal to total MTD of fact internet sales amount, fact internet sales amount, comma. So before going to create with this, what we have to do is we have to establish the relationship. So that we have to establish the relationship. Let me establish the relationship now. So go back to your model again. Go back to your model, and from the dim date to fact internet says you have active relationship and inactive relationship. So now what I will do is, so go here and come here and then right click on this particular model. So I would want to create fact internet sales to order date. Here I would want to create dim date is a table name. Here instead of date key I would take the date, and here instead of order date key I would take order date. So let me take order date and then date. So let me create the model now. So now I'm done with this. So let me save this. So now I'm done with this. So previously it has the relationship with the date key. So now I have made that particular thing to date and then order date. Now I have customized the relationship between the columns. So now come back to this particular data view. So now you can create your calculated measures. So now I would want to create the calculated measures as total MTD equal to total MTD of total MTD of total MTD of sum of fact internet sales amount, fact internet sales amount, comma dim date of date dot dim date dot date. Is this clear? Sum of fact internet sales amount, comma dim date date. So let me create this. This expression is not valid or appears to be incomplete. Please review and correct the expression. It is incorrect. Okay, let me remove this particular thing. Let me calculate this particular thing. So now here it is showing total mtd is a blank. So when it bring the data, then it would show the data. So let me see the similar way. Total mtd is fine. So now let me bring the total ytd as well, total qtd as well. Take the total qtd, and here let me take the total qtd sales, total qtd sales, and the rest of the things are same. Let me create. The expression is not valid, appears to be incorrect. Please review and complete the expression. A pass to the end of the was reached. Okay, here you have to make it qtd. Total qtd of total qtd of sum of fact internet sales amount comma dim date. So this is called as total qtd. So now in the similar way, you can go here and paste the expression, copy this expression, copy this expression, go here, put it here, and then unable to edit it. Something blocking. Let me delete this. So let me write it. Total YTD equal to total YTD of fact internet sales amount, internet sales amount, comma net sales amount, comma dim date of dot date. Let me take with this. So now I'm done with this all total MTD, total QTD, and total YTD. All this I could make it as total MTD sales, total MTD sales. So in the similar way, I could make this as total QTD sales, total QTD sales. So let me make this as total QTD sales. The similar way, this I could make it as total YTD sales, total YTD sales. So now I'm done with this particular thing. Let me save it. Let me save it, and then go back with this particular, build it, and then right click, deploy it. So I'm trying to redeploy it. Once if you redeploy it, and again whatever the cube it has in the previous tabular model, it will be overwritten. So now go back to this needs, and let me, now you have the Australia wise sales, Canada wise sales, Germany wise, and total sales. Let me refresh it. Once if we refresh, now you could see total MTD sales, total QTD, and total YTD. Is this clear? So now what you have to do is, so let me clear the grid. Let me clear the grid. So here I would want to take dim date. I would want to take dim date of. I would want to take here. I would want to take calendar year, calendar semester. Calendar semester is not required. Calendar quarter, and then English month name, and then total MTD sales. So now you could see the data. So how the total MTD sales would be populated here. You could see the data here. So for an example, what I would do is, here the data would be in terms of September, October, November. Here the data is not in proper way. So what I would do is, I will sort by this particular sales and then see the results. Let me go back. Let me go back here. Let me take one particular dim date. Go to dim date. Go to dim date. Select English month name. select English month name, and here order by, there is a order by column, sort by column name. So I would want to sort by column name, sort by column name English. There is the English month number of year. Let me take English month number of year. So let me save it. Let me save this. Let me save it. So now go back to sales info, build it, and redeploy it again. Redeploy it. So whatever the changes you made, right? Even if you made a small changes, also you have to redeploy it to the server. So I have made a small change, right? Save it and then build it and then redeploy it. Once if we come here, let me refresh here. Let me refresh it. So now I'm going to clear this window and let me bring calendar year, calendar quarter, and then I would want to take English month name and then take total MTD sales. So now this is in order, right? And earlier this was not in order. So now you could see everything is in order. Okay. So
Yes.
let me bring the total sales amount as well. Go to fact internet sales. Let me bring the total sales amount. So now you have this total sales amount as well. So now if you see here July, you could see the total sales amount would be July 2000 calendar year sales amount 690.99, 3374, 3399, 3578. All these things would be there. Let me open this. This is July, and this is August. August. Why it has three English month names each day wise? It should come only one, right? Total MTD sales. Calendar quarter. Okay. 2005 calendar quarter 3 and then July. So this is the summation of all this amount. You have to summation of all this amount, and total MTD sales would be. So we do one thing. We'll pull this data into Power BI and then we'll analyze it. Here, if you see somewhere this data somewhere the split is not coming properly. So what we could do is or else what we can do is total sales is there. Let me take the total sales instead of the sales amount. So now you could see the sales amount. Okay, now. So now you could see that July you have came correct, right? July is 47 473k. Is this clear? July 470k and August 50, and like this it should come. And if I keep total QTD sales, let me keep the total QTD sales. Now you could see uh, total MTD sales 47 473k plus 506k, which is 979k. Is this clear? And 979k plus 473k, which is 1.45 million. Is this clear? Naidu, this is
Hello.
this is the cumulative sum of totals. Is this clear? Cumulative sum. So earlier we have seen, right, in the total MTD calculation, total MTD and total YTD and total QTD calculation, we have seen, right, the cumulative sum of each month. So here if you see the total QTD is nothing but quarter to date. So for the third quarter, if you see the third quarter, July, August, and then September, the summation of July, August, and September, it will give this particular result. And again, if you go to October, November, and then December, the summation of October, November, and December, it will give you the total QTD sales. And
Yeah.
again, January, February, March, the summation of January, February, March, it will give you the total quarter. Is this clear?
Yeah.
So, and even if you take the total YTD, so the total YTD, it would be so like this. It would start from January. It would start from 2006 January, 2006 January to 2006 January to December till here. January plus February plus March till December. So if you count, if you take this particular sales and summation of January to December, you would get this particular result. Is this clear?
Yeah.
So and if at all, if you want to filter the some particular results, you could filter it. For an example, I have this particular data, right? So I don't want to see all the data. I wanted to see only for 2005. So let me take this calendar semester, calendar year into this particular country, and here go here, and then filter on the basis of 2005. So I should get only the 2005 data. Is this clear?
Yes. So.
So you can filter the data. You can filter the data on the basis of dim date. So now I have filtered the data on the basis of dim date. So in the similar way, you could go here and then you could create as many as measures you want. So we have seen the calculated column. We have seen the calculated measures we have seen. So now I would want to create some hierarchies. How you could create the hierarchy? So go to dim product. So before going to create any hierarchy, first uh, I would want to bring one particular column equal to related of dim product subcategory, dim product subcategory of English product subcategory name. Sorry, English product subcategory name. English product subcategory name. So this, let me take this as product subcategory. So here I have the names. All these are the names. So let me take this as product subcategory. Product subcategory. So now I'm done with this product subcategory. So in the similar way, I would want to create one more column. So let me create one more column here equal to related of dim product category, dim product category of English product category name. So here what I'm trying to do is I wanted to create one hierarchy. I wanted to create one hierarchy. The hierarchy describe product category name, product subcategory name, and product name. So in the product table, we don't have product category and subcategory. So that I'm trying to pull product category from the product category table and product subcategory from product subcategory table. How you can bring the data into product table by using related function. So here product category. So this is product subcategory and this is product category. So now I brought two columns here. So now these are the two columns here. So now go back to your dim product table. And now what I'm trying to do is go back to here, go back to model view. And in the model view, you have a dim product. So come here, dim product. So now you have these subcategory, product category, and then you have product English name. So now come here. So click on this product category and then create a hierarchy. So once if you create a hierarchy here, it would be creating. So this is called as product hierarchy. Take this as product hierarchy, product hierarchy. So now I'm done with this thing. So next what I would do is, so product category is there. Bring the product subcategory under product category. So now I have product category and then product subcategory, and then bring product name as well. Bring product name as well. No, it did not come. So now I'm done with this. Product hierarchy has product category and product subcategory and then product name. So this particular hierarchy has all these three fields. So now let's save it. Let's save it and then redeploy it. Sales information, build it, build succeeded, and then redeploy it. Once you redeploy it and this whatever the changes you made, right? So whatever the changes you made, all the changes would deploy into the server and go back to this particular server. Now here, let me refresh it. Let me refresh it. So now go back to this particular dim product. So now you could see the product hierarchy and bring the product hierarchy into this particular sales. So now you could see the sales data, how it would be. Is this clear?
Yeah.
So now I would want to bring only one particular product category name. So let me pull here product category name. So I would want to keep only the bikes information so that I will get only the bikes information, or else I would want to keep only the clothing information. So let me keep only the clothing information. So clothing, there are no results. I would want to keep components. Components also no results, I think. So let me keep accessories. No accessories, we have the results. No accessories also we don't have results. Under 2005, we don't have results. Let me take 2007. So now is this clear?
Yes.
So once as soon as let me see, as soon as you create the query, right here on the top you have the design mode. Just click on the design mode. It will be converted into the MDX query. This is called as MDX query. So
Okay.
automatically the query would be generated. You don't need to do anything. So automatically the query would be generated. So normally here you have the mode. So once if you browse the results in this and then go here and then click on the design mode, and the query will be created automatically. So you take this particular query and then go to MDX query. This is the MDX. Go to MDX query and connect to the MDX and then right click on here and then execute, and you could see the results here. Select non-empty. So this is particular all members executing the query. Execution incompleted. Select non-empty measures. So now we are in the product sales. Let me go to the sales info. So now sales information. Now is this clear?
Yeah.
So this is how it would be created the data. So let
Okay.
me close this thing. So this is how today what we have seen. So what is a tabular model? What is the multidimensional model? How we can create the tabular model in SSAS, and and how we can create a calculated column, calculated measures, and whatever the calculated measures. Even you could create a total MTD, total QTD, and total YTD, and even you could create the measures as dates MTD, dates YTD, dates QTD, and even you could compare the data last year data versus this year data. You can compare, and even you can compare with the last 14 days data, and even you can write a measure for the last 2 years of data, current year sales versus last 2 years data. And also you could write last 3 months cumulative and last 3 months cumulative moving averages. So all this, so whatever the calculated measures we have written in the whatever the calculated measures we have written in the Power BI, right? The same all the set of measures you can write in the SSAS tabular model itself. So there is no difference in the Power BI data model what we have created in the SSAS tabular model. But this SSAS tabular model is dedicated for this particular data. I mean, you could fetch the data, and the data it would be stored in the RAM. Is this
Okay.
clear?
Yeah.
So we'll close the session today, and tomorrow we'll see how we could pull the data by using the DAX queries. As of now, we have seen here, and there is a DAX queries, and how we could pull the DAX, how we could pull the data by using the DAX queries. So that we could see on tomorrow.
Okay, sure.
Yeah. Thank you, everyone. Thanks for joining.